Hello and welcome. Introduction. In this video, we're going to look at our first Arm Cortex M4 assembler program, and we will also look into how to debug this program using the Keil uVision IDE. First, Arm Cortex M4 assembler program. So this is our first Arm Cortex M4 assembler program. Basically, the program will add these two hex value and then store the result in register R3. Now, I'll explain each line of the program in this part of the video. All right, so the first line is this. Now, the area, this word here, is a directive that defines a section of memory in which the code is stored. Now, my first is the name given to this area, and this can be viewed as a label for this section of memory. Now, it doesn't have to be my first. You can give it any other name of your choice. The next one, code, is an attribute for the area, and it contains executable instructions. Next one, read-only, is another attribute for the area, and it specifies that the contents in this area is read-only. What that means is it means that the contents cannot be modified during program execution. And a line equals 4, basically that arrange the code on a 4-byte boundary. Now 4 is used because the Cortex M4 is a 32-bit processor and naturally aligned to 4 bytes. Now this can be 2, 8 or 16. Now the next 3 lines of code, this one here, entry, is a directive used to mark the entry point of the program. Export is a directive used to mark the symbols such as labels or function, and it make it visible to other parts of the program. So in this case, our label here or symbol is __ main, which is this here. And in this example, export makes the symbol __ main. Take note, this is 2 underscore. Accessible for linking with other modules or files. And proc here, PROC, proc is a directive used to define the beginning of a procedure or a subroutine. Now the next 3 lines are basically the Arm Cortex M4 instructions. All right, so let's take this line here, that is MOV R1, comma, hash 0x. 0x here denotes hexa, so it's 00000032. This instruction basically copies this hex value, which is 50 in decimal, into register R1. So basically this instruction will copy this value into register R1. The next instruction basically is similar or identical to this, but instead of copying 32 hexa, it copies 00000063 hexa. Copy this value into register R2. And then the third instruction basically adds the contents of R1 and R2, basically these 2 values, add them up, and then store it into register R3. Now, before I go any further, I would like to explain very briefly what are registers. Now, here is a CPU block diagram. All right, I've taken this diagram from the TM4C123GH6PM microcontroller datasheet, and it's on page 71. And I like to highlight this part. This is the Cortex M4 core, the CPU. And the registers are stored there. All right, so R0, R1, R2, R3, they are all general purpose registers. All right, they are 32 bits wide, and they are capable of storing 32 bits of information, and they are stored here because you can manipulate the data stored here during the execution of the program instructions. All right, so let's get back to the program. So the next 3 lines of code, the first one here, this is stop. This is a label. Now it doesn't have to be stop. It could be any other name. All right, but I've used stop here. B is a Arm Cortex M4 instruction. Basically, that stands for branch. And this instruction here, branch or B stop, basically it says branch to stop, which is this part. So the program will now keep jumping to this point. And that's why I put the comment says stay here. That means it will stop here and keep jumping at this point. And then finally, no, not finally, the next one is ENDP. That is a directive used to mark the end of the procedure or subroutine. And then finally, end here is the directive that marks the end of the entire assembly file or assembly program. Now we will type this code or this program into the Keil MicroVision IDE and see how it works. In this section of the video, I'm going to walk you through the steps of creating our first Arm Cortex M4 assembler code using the Keil MicroVision IDE. I'm going to assume that you have installed the Keil MicroVision IDE, the Stellaris driver, and the Stellaris add-on. If you have not got this software ready, please refer to my previous video on how to do that. So the first thing to do is to start Keil MicroVision IDE. Okay, so after you have started Keil MicroVision IDE, you'll be presented with this screen. All right, so the first thing to do is to start a new project. Now to do this, go to project, this toolbar up here, go to project, click on it, and then select, look for new MicroVision project, which is this one here. Click on it, and then this create new project dialog box pops up. Now in the file name box, key in the name of your project. Now the name of the project is entirely up to you, of your choice, but for this video, my project name would be lesson 1. All right, once you keyed in or type your project name, you save. You click on save. And then this dialog box pops up. It says select device for target. Now in the search box, you type in the name of the device. For our project, our device is TM4C 123 GH6PM. All right. Or the other way of doing it, if you wish, is to go back to the original starting part of this select device. you can expand Texas Instrument, look for TVAR-C series, expand that, and then go down, look for TM4C123. So you go down, you look for the device name. Ours would be, so it's a little bit time consuming, and you'll see this, and eventually you highlight that, or like what we done earlier, we just type in TM4C123GH6PM. You highlight that, all right, and then click OK. Now you'll be presented with this dialog box. You look for CMSys, which is this one here, expand it, look for core, and then check this box. Then you go down the list, look for device, click on device, expand it, and then the startup box here, you check it. Once you've done this, once you check these two boxes, then you click OK. And then go to the project panel, which is on the left-hand side here. Expand the target one. All right, and you'll see CMSys and then the device included in the target one. Now, what we need to do is to highlight source group 1. Right, highlight source group 1, right click, and then look for add new item to group. All right, let me just do that again. Highlight source group, right click, look for add new item to group, click on that. Then you'll be presented with this dialog box, add new item to group. You look for the ASM file .s. Click on that one, and you notice in the type box the ASM file .s option appears. Now in the name box, you key in the name of your ASM file, the assembly file. ASM stands for assembly file. Now, I usually use the same name as my project name. So my project name is lesson 1. So I would just type in lesson 1 and click on add. Now, this name here is of the choice. All right, you don't have to use. It's entirely up to you. So once you've done that, you click add, and this panel appears. This is where you type in your source code. Now, in our case, the source code is the one that we have discussed earlier. Now, what I'm going to do is I'm going to be lazy. I'm going to just cut and paste the source code. All right. Here's my source code. Now you notice that I have tabbed this first line. The source code has to be in this format. All right. The area has to be at least one tab away from the edge here. All right. So this is the source code is typed in, or in my case, I paste it. Now, you notice there's an asterisk next to the name of your file name. That means this file is not saved yet. So what you need to do is go to this option here in the toolbar here. You either click save or save all. Now, either one will do. So I will just click save. Notice the asterisk now has disappeared. That means this file is now saved. and is included in the source group. If I expand this, you see the file is included in the source group. It's been added to the source group. Okay, once you're done saving the file, go back to the toolbar up here, go to project, and this time in project, you go down, you scroll down, and then look for build target, click on it, and look at the output, build output panel. You may see 0 errors, that's good news, and 46 warnings. Now, it's a good thing that we don't have 0 errors, because when the compiler encounter an error, it cannot generate an executable program or object file. So 0 error, errors with bad news. All right, it won't generate the executable file that you need to run the program. Now, on the other hand, warnings, it's not as bad as errors, but they could be potential issues or problems when you run the file, when you run the program. So it will still run. It may run the program without any hitches, but it's good to try and get rid of these warnings. So to get rid of the warnings, you go back to project, and then no, you don't. You go to the project panel. All right, go to the project panel, highlight target 1. All right, highlight target 1, right click on it, and look for the options for target, click on it. Then when the options for target dialog box pops up, look for C/C++ bracket AC6 tab. Click on that one, and then go to the section where it says language/code generation, and then look for language C box. Click on this down arrow key, the drop down box, and the moment it says C90, click on this down drop down box, look for C11. All right, look for C11, select that, and then click OK. Now go back to the project option in the toolbar, click on project, scroll down, look for either build target or rebuild all target files. Click on that, and look for the build output panel again, and we still get one warning. Now this is due to this problem here. No section matches pattern asterisk brackets in root $$ sections, close bracket. Now to actually resolve this problem, go to the project panel again, highlight target 1, right click on it, look for options for target, click on it again. Now this dialog box options for target pops up. Look for linker tab, click on it, and then look for use memory layout from target dialog. Uncheck this. All right, we don't want this, so we uncheck it, and then you go down, look for scattered file box. You see there's this option here, highlight it, press delete, make sure it's empty, make sure this scattered file box is empty, then click OK. Okay, once you've done that, go back to the toolbar up here, look for project, click on it, and then go for rebuild all target files or build target. All right, either option will do. Just select build all target file, rebuild all target files option, click on it. And this time, look at the build output panel. We're getting 0 errors and 0 warnings. Debugging. Hardware requirement. Now, before we can start to debug the program, you need to connect the TMC123G Launchpad board to your laptop or desktop. All right, once you connected the TMC123G Launchpad board to your laptop or desktop, go to the Keil uVision IDE. Okay, so we're back in the Keil uVision IDE, and so the first thing, now we're going to debug this program, right? So what we need to do is, first of all, we need to go to target. We need to check out a few things. So go for options for target, click on that, and this time you go to debug tab, you click on that. Now look for this part here where it says ulink 2. Now you go down to this down arrow button, click on it, a drop down menu comes up, and then you scroll down, and the last option is Stellaris ICDI. You select that. Now you should see Stellaris ICDI if you have installed the Stellaris driver and the Stellaris add-on. I've shown you how to do this in the last video, so if you haven't done that, please make sure you've added or installed the Stellaris driver and Stellaris ICDI add-on. All right, so if you've installed that, then you should find this option, Stellaris ICDI. Now make sure you select that and then click OK. All right, now just to make sure things are done correctly, go to project again, and then go to rebuild all target files. All right, you should get 0 errors and 0 warnings. Now you may have done that before, but I usually do it again just to make sure. Now at this point, the board, the Launchpad board, should be connected. Now that we have rebuilt the target files, so what we need to do now is to download the program, the source code to the what do you call board. Now one more thing before we do that, go to target again just to make sure. Options for target, then output tab. Make sure you click on this one, create target, create hex file, and then click OK. All right, now this time, all right, so to download the file to the board, you can either use this option here. Let me just enlarge this part here, the load option here, or you go to debug, go to flash option, and then download. All right, F8. So either way would do. So since I've up here, so I'll select download and watch the build output panel here, and it says erase done, programming done, verified, okay. So what that means is once you see this message, verify OK, that means the code executable file is now on the board, the Launchpad board. Now the next thing is we want to do the debug. Now, what we need to do is to set what we call breakpoints. All right, what that is, you see my cursor is flashing up here. Go to line 7, place your and then click on it. Make sure your cursor is flashing at line 7. Then go to debug and then look for insert/remove breakpoint. So click on that one and you see a red circle next to line 7. Move your cursor down to line 8. Go to debug again and insert another breakpoint, and then go to line 9. Make sure your cursor is flashing there. Go to debug, insert or remove breakpoint, click it again, and you see 3 red circles now. One at line 7, next one is line 8, and next one is line 9. Now these red circles here denotes breakpoint. That means we can run the program. All right, go to debug. We can start debug. All right. And then you see the startup file is here. We go back to lesson1.s. Yours could be another name, but I click on that. You see these 3 red circles again. Now you go to debug. Okay, before we do that, before I run the program, now on this side of the IDE, the panel is called the register panel. Now notice the registers R0, R1, R2, and so on are listed in the register panel. All right, so take note of this. So all your registers are here. Remember, we talked about it a few moments ago at the beginning of the video, the registers, so you can see them in the register panel. This only appears when you are in a debug session. Now go back to debug and then go down the menu and then look for run, which is this one. Or if you want to use F5 function key F5, but I'll click on here. All right. Now the program has executed and stopped here. The red dot, the red circle here means breakpoint. That means execute the program and stop here. Notice you get a yellow arrow. Let me just like zoom in here. See this yellow? That means the program has executed and stopped here at line 7. Now let's go back to the program. Now it has executed this instruction. Remember what this instruction do is to copy this value 32 hexa into register R1. So go to the register panel and look at register R1. So we need to kind of expand this a bit, and you'll see 32 0000032 hexa in R1. And the program now has stopped here. Now I'm going to run the program again. Now before we do that, what is going to happen? What's going to happen is it will execute this line of code here, which is copy this value into R2. So we should see R2 with the content 000000063 here. This register R2 here. All right, so go to debug and select run again. See the yellow arrow key stops here, and look at R2. We're getting 63 hexa in R2. So now we have these two values in the respective register, R1 and R2, which is here. We can see this R1 now is 32, R2 has got 63. Now we go back here. If I were to run it again, this time what does it do? Remember, add R3, R2, R1 means add the contents of R1 with the contents of R3, which is 32 plus 63, and what happens? It will store it in R3. So R3 would have the result. What would that be? That would be 595. We should 95 hexa should appear here. So I'm going to go to debug, select run again, and this time the yellow key, the yellow arrow is pointing at line 9. All right, just to satisfy curiosity, is line 9. All right. Okay, but look at, let's check R3. R3 has 95, so the program has successfully added the contents R1 and R2 and then stored the result in R3. And then finally, we're going to execute this program here, this line of code. Which line of code, what does it do? It will branch and stop. Branch to stop, that means this point here, so we will stay here forever. But we just go debug, run, and it stops there. All right, so that's how we debug a program in Keil uVision IDE, and we also seen how this 3 lines of code works. Okay, that's it for this video. Thank you for watching, and I'll see you in the next video. Bye.